What is crack propagation in material fracture? Have you ever wondered how a small crack in a material can lead to a complete failure? Let's break down the fascinating process of crack propagation in material fracture. This process is all about how an existing crack grows under stress, eventually causing the material to fail. It all starts when a crack is initiated, often at a defect or a point where stress is concentrated. Once that crack forms, it can grow as the material is subjected to continued loading. Crack propagation can be divided into two main stages: crack initiation and crack growth. During crack initiation, a small flaw or imperfection in the material begins to form a crack due to stress. After that, the crack starts to propagate, which means it grows deeper into the material as the applied stress pushes the crack tip further along. A key player in this process is the stress intensity factor. This factor measures the stress state near the crack tip. As the applied stress and the crack length increase, so does the stress intensity factor. When this factor surpasses a critical value known as fracture toughness, the crack can grow rapidly, leading to sudden failure of the material. The properties of the material itself play a big role in how crack propagation behaves. Materials that have high fracture toughness and ductility tend to resist crack growth better. They allow for more plastic deformation before they actually fail. On the other hand, brittle materials with low toughness can experience faster crack propagation, leading to sudden fractures. Environmental factors and the type of loading also influence crack growth. For instance, higher temperatures can speed up crack growth in certain materials. Additionally, cyclic or repeated loading, often referred to as fatigue, can cause cracks to grow gradually over time. Moisture or corrosive environments can weaken the material around the crack, accelerating the propagation process. On a microscopic level, crack propagation involves complex mechanisms. These include the formation of microcracks, separation at grain boundaries, and cleavage. Depending on the internal structure of the material, these processes can either slow down or speed up crack growth. Understanding crack propagation is essential in the context of product failure and mechanical breakdowns. It explains how small flaws can develop into critical fractures that lead to catastrophic failures. This knowledge is vital for engineers as they design components with better resistance to cracking, choose suitable materials, and predict service life by monitoring crack growth under operational stresses. In practical terms, controlling crack propagation involves improving material toughness, minimizing stress concentrations through thoughtful design, and applying protective coatings or treatments to reduce environmental effects. Regular inspections and maintenance can help detect cracks early, preventing them from growing to dangerous sizes. Overall, crack propagation is a fundamental mechanism of failure that connects the microscopic behavior of materials to larger mechanical breakdowns, showing how tiny defects can lead to complete fractures.